Morning, students. So today we are going to learn about permutations. So generally permutations are nothing but arrangements which follows a particular order. So we can arrange all the things or we can take some things and we can arrange, right? So generally these permutations are two types. One is called linear permutations, another one is called circular permutations. Linear permutations are nothing but arranging the objects or things or persons or whatever it may be on a line in a straight line way. And circular permutations are nothing but arranging the objects in a round table format or in a circular format, right? So first we'll go complete details about linear permutations. So these linear permutations are again classified into two types. So arrangement of the dissimilar objects means different objects will be there and we have to arrange. For example, if you take A, B, C, D, all are different. So arranging the different objects and arranging the similar objects. Similar objects means A, B, C, D, like that. Here A, two A's or three A's like that. So that type of similar objects also will be there, which we have to arrange. So in the dissimilar objects, we have again two more cases. What is that is repetition of the things not allowed. So same object will not be repeated twice. So generally if they did not mention anything, we can consider it as a linear permutation. And if they did not mention anything, we can feel that it is a repetition is not allowed. Right, students? So first one is repetition is not allowed. So second one is repetition is allowed. The same thing will be repeated any number of times possible. Right, student? So here is I have n objects. From those n objects, I want to take r objects at a time, or I want to arrange r objects at a time. That can be done in NPR ways. That can be done in NPR ways. So here NPR is nothing but number of permutations of n dissimilar things taking r at a time. Number of permutations of n dissimilar things taking r at a time. That is also called as filling of r empty places with n objects. Filling of r empty places in a line with n objects. So that can be done in NPR ways. If I am doing complete all the things I am arranging, that can be called as NPN. We call that is n factorial. We call that is n factorial. And I think all of you know what is NPR. NPR is nothing but n factorial by n minus r factorial. Now similarly, when repetition of the things is allowed, that can be done in n power r. Can you say? That can be done in n power r. So students, so today we'll completely discuss about this NPR and its applications. NPR and its application. So I'm going to discuss one by one completely about NPR and its applications. So NPR, nothing but what? Number of permutations of n dissimilar things taking r at a time. That's it. This is also called as number of arrangements, or number of ways of filling r empty places. How many empty places? R empty places with with n objects. With n objects. I think all of you got it. Right, student? So this is nothing but what's the formula we got? N factorial by n minus r factorial. For example, my r become n means I want to fill every object in n brackets. Therefore, that can be done in filling of all the things is n factorial by 0 factorial. We can call it is n factorial. So these are the basic things you have to understand before you are going to do questions. So generally in this chapter we will get objects such as human beings. We will get letters. We will get digits. We will get words and arrangements, and we'll get some flowers, garlands, or balls, different types of white balls, red balls, or fruits, 100 apples, 20 apples, like that. So depending on the question, you have to apply, but you have to check, is it linear? First point. Second point, is it dissimilar or similar? Next one, is it repetition is allowed or not allowed? So three things you have to check, students. So the point one we have to check it is, point one we have to check it is, or four things we have to check. Point one we have to check it is it arrangements? Arrangements means compulsorily it has to follow order. Or is it combinations? Combinations means selections. So no order. Order is not important. Only grouping is important. We'll discuss it later. So point number one, we have to see. Whenever you look at a question, you have to see, is this is belongs to permutations or combinations? Point number one. Point number two. Point number two. Is it dissimilar thing? Is it linear or circular? Linear or circular? That is a point number two you have to see whenever you are going to do any question. And point number three you have to see is it dissimilar or similar? Dissimilar or similar? Got it? And point number four, four steps are very important. Point number four is it repetition is not allowed or allowed? So these four things you have to see whenever you are doing a question in a permutations and combinations. Right, student? Shall you repeat again? Is it belongs to arrangements, or that is permutations, or combinations, that is selections? So main key point is arrangements you have to follow a particular order. In combinations, no need to follow any particular order. Only just grouping is enough in selections. And the second one you have to look at is the permutation is linear or circular? Is the combinations is linear or circular? And the next one is it dissimilar or similar? Next one is it repetition is allowed or not allowed in the given question? These things you have to check always whenever you are going to do any problem based on the permutations. Right, student? So here is one question I want to go with. So today I said, na, we are going to discuss about linear, dissimilar, and no repetition. What is that? Today we are going to do linear permutations, dissimilar, and no repetition, or repetition is not allowed. So these cases now I am doing for you people. So just check it. Question number one, I am going. I said, now we can arrange the letters of the word or letters, or we can arrange the digits, and we can arrange the boys, girls, like this. So now I'll go with the first letters, problems based on the letters. So I'm taking a word called flower. I'm taking a word called flower. So how many letters are there in this flower? 6 letters are there, right, student? So question number one, what I'm asking is, I'm asking a question based on NPR. NPR. So total N is how much here? 6. Number of 4-letter words possible with the word. Number of 4 letters words that can be possible by using all the letters of the word flower. So by using all the letters means 6 letters I am using. But number of 4-letter words formed is dash. That can be nothing but 6p4. Na? Number of 4-letter words is, so 6p4 is nothing but number of 4-letter words. With all the by using all the letters of the word flower. By using all the letters of the word flower. I think all of you got it. By using all the letters of the word flower. Right? Any doubt? So the next one is by using all the letters possible. Number of permutations possible by taking all the letters of the word. By using all the letters of the word. Number of permutations possible by using all the letters of the word. So here I said 4 letters only I said, but now I am saying that all the letters means 6p6 na. That's nothing but 6 factorial. Got it? Third question what I am asking is number of words that number of 4-letter words. Try to understand. Number of 4-letter words that can be formed with the flower but starting with F. So I need 4-letter words. Look here, I need a 4-letter words, but that should start always with F. Means now I am fixing here F. I am fixing here F. That can be done in one way. I can fix one letter F in one place in one way. So now I have to do is remaining 3 empty places, have to fill with how many? Remaining repetition is not allowed, be very careful. So remaining one letter is over, so another 5 letters is left. 5 letters, n is 5 and empty places r is 3. So that can be done in 5p3 ways. So my answer is 1 into 5p3 because it's a continuation means product. Right, student? Now I am going to the fourth question in the same thing. So what I'm asking is number of arrangements containing F. Number of arrangements, number of arrangements containing F. Containing F when the letters of the word flower are taking 4 at a time. See, containing F. F should be there, but 4-letter words I want. 4-letter words from the words flower. So very simple. Don't get any confusion. Here, what is the basic difference between earlier question and this question is, I should have F, that's it, containing F, but it's a 4-letter word. So that F can be in the first place, in the second place, or in the third place, or in the fourth place. So F can be any of the 4 places. I think all of you got it. So F can be arranged any of the 4 places. Any of the 4 places. That can be done in 4 ways. Right. Next one is 3 places will be there na, but 5 letters will be there. So remaining 3 places can be filled with 5 remaining letters. That can be done in how many ways? 5p 3 ways. So the total ways are 4 into 5p3. Have you got the basic difference between earlier question and this question? In the earlier question, F should be in the first place. He's fixed it. It's fixed. Means that can be done in one way. And the remaining we are filling it in 5p3 ways. But here the word F contains only. F should be there in the 4-letter word. But he did not mention where it should be. That's why we can do this in 5p3 ways, the remaining 3 places. Right, student? So in the same flower, fifth question, number of words that starts with a vowel. Number of words that starts with a vowel. Number of 4-letter words, I can say. Number of 4-letter words that starts with vowel. Condition is, so it should start with vowel. Got it? So the words should start with vowel. So what is the first place can be filled in? How many vowels are there in the flower? In the flower, I have vowels as E comma O. 2 vowels are there. So the first place can be filled in any of the 2. But be very careful. In the first place, any of the 2 means either E or O. Either E or O. So 2 ways I can do. And how many letters left? We filled only 1 letter here. So another 5 letters left. These 5 letters can be filled in 5p3 ways. I think all of you got it, students. Because I need a 4-letter word, but first I should start with vowel. So among E and O, how many vowels are there? So 2 vowels are there. First place can be filled any of these 2, either E or O. So that can be done in 2 ways. And the remaining 3 places can be filled with, only here 1 we will fill. Among E and O, if I fill E means O will left now. So O plus remaining 4, total 5. 5 letters, 3 gaps, 5p3. Now, sixth question is, number of 4-letter words that can be ended with a vowel is. That can be ended with a vowel is. So can you give vowel ended with a vowel is? So here is a 2 now. The same way you will get again ended with vowel or starting with the vowel. So students, so it's very easy if you got a clarity in the application part. So nothing to worry much here. And then next I'm going to one more set of questions. I'm taking this question. Look here. I'm taking one question here. 5-letter words that can be formed. 5-letter words I want students. 5-letter words that can be formed from the word that can be formed from the word consider. From the word consider that are begin with C and end with R. That are begin with C and end with R. End with R. How many letters word we required? We required 5-letter words here. Very simple. 5-letter word. So take first 5-letter words here. 5 boxes. 1, 2, 3, 4, 5 boxes. So 5-letter words from the word called consider. How many letters are there here? Actually 7 are there. So 7 are there. So what I want is that begin with C and end with R. So first fix C here, R here. So 2 places I already fixed with the 2 letters. So I think all of you got it. So C can be fixed in one way and R can be fixed in one way. Right, student? So remaining 3 empty places. How many empty places are there now? So remaining 3 empty places can be filled with. So we have to fill these 3 empty places with remaining letters. How many letters left? So total 7 means total 7 or 8. Total 8 letters. So in that 8 we've already taken 2. 6 letters left for 3 places. That can be done in 6p 3 ways. I think all of you got it. So number of ways will be 1 into 6p. That's it. Simple. Right, student? So similarly, I am asking one more. In the above question, question, otherwise I will check one more. Look here. Different words beginning and ending with the vowel that can be formed with the letters of the word equation. Different words. So very good question. Different, the number of different words that can be formed, number of different words that can be formed, number of different words that can be formed by taking the word equation, by taking the word equation, which are beginning and ending with, a vowel dash. So the options are 14400, 4320, 6864, 1440. So you people try this question as a homework. If you won't get it, I will help you. Right? So this is such a very nice question. Now what is given is number of different words. He did not mention how many words. So 2 letters words, 3 letters word, 4 letter words. You just check it all and you mention that in the chat box what is the answer you got. Right, student? So thank you, and please do subscribe the channel and please share this with your all friends, and please do comment in the box. And I want to do all these permutations part by part, and I want to help you students, because from permutations and combinations and probability almost you will get 7 to 8 Eamcet questions, and minimum 2 to 3 questions in mains. Right, students? So please do subscribe and please share it and like it and please mention it in the comment box. So thank you for watching. Ramarao Pulibandla. Bye bye.